So what is EXT4? Well, before we get to the answer, a bit of background may just be required. See, EXT4 is only the latest, although not particularly new, iteration of the venerable Linux Extended File System, or EXTFS. Now, EXT4 started as a set of extensions to, sure enough, you guessed it, EXT3, and what do you know? EXT3 was itself an evolution of EXT2, which was actually the offspring of EXTFS, the original, the OG Linux-specific file system. Yeah, so EXTFS was actually created by Remy Card and others to overcome the limitations of the Minix file system employed by Linus Torvalds, the first Linux kernel. Minix, approximately 1987, was written by Andrew S. Tenenbaum and is a Unix-like operating system. The man just wrote it for the benefit of higher education so that Unix could be taught without paying a considerable sum for the real deal. But like I was saying, the Minix file system has its limitations, hence EXTFS was extending it. All right. So EXT4 was added to the Linux kernel in 2006, EXT4 dev, the repositories in 2008. It's what's known as a journaling file system as of EXT3, and it basically means that it's a list of impending and implemented changes gets maintained. So it's a bit different than your diary in that its most recent entries describe what will happen rather than what has happened. So a combination day planner journal, if you will. So this journaling, which actually is optional, makes it possible to quickly repair file system errors without using any kind of utility like E2FSCK to traverse the entire data structure in search of, wackiness. So EXT4 is a standard root tree file system with a boot sector, partition table, and like the Unix file system, uses inodes or index nodes to describe files and objects. It offers transparent encryption, uses checksums on the metadata, journal, and other, supports trim, and implements delayed allocation. What? Delayed allocation just means that EXT4 caches data until it can determine the quickest and most efficient way to write it. Now, it's actually a boon to performance. I know you're thinking, well, doesn't that slow things down? Yeah, it introduces the possibility that data might not be written in the case of a power failure, but it does inject some performance. See, journaling mitigates the danger of data loss in this particular scenario. Yeah. Excellent. So beyond all that, EXT4 uses 48-bit addressing that allows up to an exabyte EIB of data. So 12-bit extents, which describe large chunks of contiguous space, augment EXT3's 32-bit direct and indirect block addressing. Maximum single file size in EXT4 is 1 tebibyte. That's a TIB, capital B, and the maximum number of files is 4 billion. So these are pretty big numbers, huh? I do want you to remember the main advantages and disadvantages of EXT4. So the upside is long and successful track record, very good performance, handles up to an exabyte of data, that's EIB, and 1 million tebibytes. Journaling operations make error recovery quick, and it's always going to be backwards compatible with EXT3. But like I say, every upside's got a downside. It does lack newer technologies such as copy on write. There's no integrated volume manager as with BTRFS and OpenZFS. And it doesn't support Windows natively. There are some third-party drivers available. They are free and they're from Paragon Software. So then when would you use it? Well, because EXT4 is fast, tried, and true, not to mention the default file system for Linux, it's perfectly fine for end-user fans of Tux. For NAS, for servers, or for any situation where fault tolerance and data integrity are more important than speed, BTRFS or OpenZFS might just be your better bet. So we're going to wrap it up here because you've learned all about EXT4. Stick around, though. I want to see you in the next video.